All right. Climate change. What's climate change? Somebody give me some thoughts. What is climate change?
Well, it depends on who you ask, because climate change can affect a lot of things.
So it depends really on the question I'm asking. What are some things it can affect?
The ocean levels,
So sea level rise?
biodiversity, it's affecting a lot of species, plants and animals.
So it's affecting plants, animals. What are some things we're seeing with climate change? Increasing global temperatures. Changes to global precipitation patterns. And for climate change, those are our main two things because the climate for an area tends to be dictated by its temperature, its rainfall, and sometimes its soil type. So changing the temperature and the rainfall in an area is going to change its climate. If somebody asks you why should they be worried about climate change, what are you going to tell them? Why does it impact me?
This is related to this question in the textbook and like the quiz that we had to do on this. One of the questions was like, what's not a reason for caring about climate change? And I was like, what? And none of them seemed like they
I'll take a look at it.
Be a reason. Well, I read it in the textbook and it was like saving the earth is like not why we should care about climate change. And I don't really understand what it was getting at there. I think maybe like it's like going to affect human life and like our civilization will die out if we don't.
I think their concept is the earth will continue regardless. The earth just won't continue the same.
Okay.
And for getting your average person to care about climate change, saving the earth is not the way to go.
So it's about saving humanity.
It's about saving humanity or saving animals and plants.
Okay.
That's what's going to get a lot of people to do action, right?
I'd say even like saving your way of life.
Saving your way of life. Get your civilization. I mean, there are groups of people that are having to think about what are we going to have to do if we have to move and lose our identity and our culture. For a lot of people, if that was them, that would be their reason to care about climate change. For some people, they're going to care because they know those other people exist. But for a lot of people, saving the earth, for some people, they don't believe we can save it. So that's that fatalistic trap that you get stuck in, that it doesn't matter what we do, we can't actually save the planet. We can just make it a little better. Then there's the concept that it's not our job to save it. So that one just gets a little murky. And it's too much responsibility. For some
That
people.
makes sense. I was just, the structure of the question confused me. I was like, you don't want me to save the earth. But that now makes sense.
I want to save the earth.
I think
I'm called to save. I think we're called to save the earth.
Like from a Christian perspective,
Yes.
You could say like the earth is created, and so we do want to care for it, like because it is good. Whereas maybe if you weren't Christian, you would be like, well, it doesn't matter to me whether the earth is here or not, but I want to be here. So
Correct. So all of those are reasons why we should be worried about it. Are we sure that climate change is related to humans? How do we know that? We'll talk more about that. How do we know climate change is actually happening? Because, like, I was watching the news and, like, these people told me it wasn't real. I was watching a talk show and people told me it wasn't real. Or I read something on Facebook the other day. It looked like it was from a real site. How do I know climate change is really happening? Is this a question you all have been asked at some point in our time? If not, you will be asked this question at some point. Because people are going to be like, you're a scientist. You should know this. Even if you go to med school, you may still be a scientist. You should have an answer. Are we sure it's related to fossil fuels? What if it's natural? The one that I always like is, what if it gets warmer? I don't really like winter, so I don't mind if it's a little warmer. How is that bad?
I mean, they eventually will have beachside properties.
Beachfront property in Philadelphia. Sea level rise, warmer, no snow. Sounds good, right? For some people, it sounds lovely. Oh gosh, but God's just going to save us before it gets bad, right? Like there's like a level at which he's going to be like, no, you guys have screwed up. I'm just going to come back in and take it all away from you now. Or I'm going to save it all. Does it work that way? If so, I'm really sure the Israelites have a lot of questions because there were a lot of times there that they got like as bad as it could get. And it got worse. And Jesus didn't really come at any of those times. So it's a little, but I do know people who believe that God's going to stop it from getting bad. I truly believe God's going to stop it from getting horrible enough that we kill ourselves, all of ourselves off. I don't think he's going to let us get that far. Because I think if Christians don't act, what we're finding now is non-Christians have no problem going, climate change is bad. Let's stop it. So if the Christians aren't mobilizing, he's going to mobilize other people through one way or another. Okay. So climate change and global warming. These are two different phrases. And you know the answer to does our terminology matter is yes. How does climate change convey a different message than global warming?
Climate change kind of includes all the other like effects, like changes in weather patterns and precipitation and sea levels and all sorts of things, whereas global warming just sounds like it's getting warmer.
Do you think overall people are okay with warming? Like a little bit? Because they don't like winter. Or snow. But climate change, that's scarier.
Is climate change a newer term than global warming? Because I remember there was a time where everyone around me called it global warming.
See, in oceanography, we didn't use global warming. That wasn't what was used. In my science classes, we didn't use global warming. My professors always used climate change. And that's part of this, is that there were people who used the phrase global warming. They tended not to be a lot of the scientists. You find that scientists use the phrase climate change. And at the beginning, some people were using global warming that were scientists too, because that was the easiest way to explain it, that the earth was getting warmer. But global warming is part of climate change. And the problem is that the media launched onto that term global warming, because climate change, for the average person who doesn't understand what climate is, that sounds like something that's like totally like natural and neutral. Like, this isn't bad. The climate's just changing. No big deal. Because they also confuse the word climate with weather. So you have to have climate and weather separated in order to understand what climate change actually is. The Weather Channel this year started a big thing online educating people about the difference between weather and climate for talking about climate change, because they're realizing that people think that a big snowstorm this year means that global warming is not happening. No, that's not what it means at all. But people confuse climate and weather all the time. So you all have heard global warming more often, right? You've read it more often. This is what people talk about. This is what is on the news. I'm hoping I know the answer to this question. I'm afraid that I'm going to not hear the answer I want. Your science professors, what do we talk about? Climate change or global warming?
In high school, it was global warming.
High school was global warming. What about here?
Usually climate change.
Climate change usually? Good, good. Which phrase is more accurate? Climate change with global warming perhaps is a symptom. This is where your words matter. We're going to take a different way of looking at this for a moment. How many of you get angry when you hear somebody say, it was an organic process, it just happened? Because that's not what the word organic means. Or they say, the food is organic, and you're like, all food is organic. All food contains carbon. Or, oh gosh, my least favorite. Every time I heard Dr. Duffett say things like, it's in our DNA at Eastern, and I'm like, it's not. Eastern doesn't have DNA. We have vocabulary that means things in science. This is true in every discipline. There are words that mean things. Here's a word that Emma's going to know that I don't think anybody else is going to know. Ethnography. Have you heard that word before? You've heard it. So I could tell you that ethnography is kind of like writing a biography about somebody, but it's not at all. It's a systematic study of people's understandings of their culture and themselves and other things. But a lot of people, you look at it and you're like, oh, well, sure, it says it's an ethnography, but they just wrote this story about what this other person said, so it's a biography. The same thing happens here, as people go, it's close enough. I cannot get these things to sync. So climate change. Up until about 10,000 years ago, the climate around here was fairly stable. And by stable, I mean during that interglacial time period, it was fairly stable because we are in an interglacial time period. And it's important that we make a distinction, because you would see other times, nope, it got really hot and it got really cold. That's true. But we'd had about 10,000 years of stable climate. In 1980, the temperatures generally started rising to the point where it was measurable. And the temperatures here I'm talking about is the average atmospheric temperature. Because as you know, the temperature on any given day changes. Frankly, the temperature changes constantly. How many of you have on your smartphone something that tells you what temperature it is outside? And you see it update because then it runs to like the top of like your list of things that are going on. So you know temperature changes all the time. But this is the global average atmospheric temperature that we usually use for talking about climate change. This is when we knew that climate change was happening. This isn't when we first thought it was happening. That was way back with Arrhenius that we first had the idea that it was happening. But this is when we knew climate change had started happening. In the 80s, we were able to link it pretty well to the burning of fossil fuels, because that's what we looked at. It wasn't until later that people really started bringing in the other things that are happening. Climate change is going to affect everything. And unfortunately, as the climate changes with this, it's going to change much more rapidly than it normally would, which means we don't know how the animals and plants are going to keep up, and we don't know what's going to happen to ecosystems. What we know is that during times of rapid change, lots of things die. This is what we see in every mass extinction time period. There's something going on, lots of things die. Usually following a mass extinction event, lots of new things evolve. We're not certain that's going to happen this time, but it still could. So that there's a chance that after climate change, things could change back a different way. The problem is going to become the loss of genetic information and what that's going to mean for future evolution, because so many of our species are already stressed as it is. Climate change is going to shift water availabilities. We're going to have areas with lots of flood and areas with lots of drought. We're going to have heat waves, and we're going to have heat waves mainly in areas of lots of drought, which is a big problem, because if you're in drought and a heat wave, how do you survive? Food production is going to initially, we believe, increase in some areas. and extinctions are going to happen. Weather versus climate. Weather is short-term. Weather is short-term changes in atmospheric variables like temperature and precipitation in a given area over a period of hours to days. That's weather. You can recognize weather. It is sunny or cloudy or a blizzard or fog. You know weather. Climate is averaged weather conditions, usually averages in temperature and precipitation, in a particular area over periods ranging from at least 30 years to thousands of years. Usually we talk about climate also with seasons, because whether or not you have seasonality in an area is related to your climate. And it does require a long-term record of a minimum of 30 years. A single hot summer and a single cold winter cannot possibly predict climate change. And the definitions that I used, I actually went to the World Meteorological Association and I looked at how they define weather and climate, because their definitions are the standard for everybody in this. This gives you an idea of the major climate zones in the world. Where do we live?
Between warm temperate and cold temperate.
We're in the temperate time zone. Temperate, yeah, we're right on that border between warm and cold temperate, aren't we? You can see that the red arrows are your warm currents of water, and the blue arrows are your cold currents of water. The one that causes El Nino, southern oscillation events, southern oscillation events, is the one that's supposed to be taking warm water this way to the other side and up towards India. When this breaks down and the warm water goes this way, is when we have big problems. There are three main differences for climate dealing with average temperatures. We call them the tropical, the temperate, and the polar areas. The difference in climate has everything to do with heat and moisture distribution. And heat and moisture are distributed unevenly around the world. The gradient between those heat and moisture differences causes a lot of winds. The winds cause currents. We have our three main climate zones, the tropical, the temperate, and the polar. They are created by the unequal heating of the planet and the rotation of the Earth on its axis and the winds and currents that result from that. So we get these three large circulation cells between the equator and 90, so I guess we really have 6 of them. You have 0 to 60, 60 to 30, 30 to 0. We find that the cells alternate how they move air depending upon where they are north and south of the equator. The spin of the Earth creates the wind currents, and then we find that our water currents start at a 90-degree angle to the wind, and with each subsequent layer of the water, it spirals down, changing angles. If you want to ever do the physics and math for that, it's called Ekman spirals with Ekman transport. Please don't make me do the math, but we can do it together with a textbook. The most complex math I think I ever did was for those things, because you slice the water infinitely smaller and you can look at each of the transport rates. Physical oceanography is like physics and like calculus on crack with like imaginary water movements. I don't even know what to tell you about it. It was terrifying. And my professor would just keep saying, "You're all biologists, you don't understand." We'd all raise our hands and go, "Nobody in here is in a biology lab." "Are you physicists?" "No." "Then you're biologists." Those are all that there is. Engineers were also biologists, in case you were wondering. They were not physicists either. Chemists, geologists, they were biologists. There's physics and everything else. He's a fun guy. So this is looking at the Earth's climate system. You know we have to have greenhouse gases, otherwise we're a frozen ball of ice. Without them, we die. With too many of them, we may also die. Somewhere there's like a nice little layer in there that's good. And this shows you the warming and the cooling processes. I'm not really going to touch a whole lot on these because, well, they're really easy to understand. Our greenhouse gases of water, carbon dioxide, methane, and nitrous oxide are big ones. Keep heat in to keep us warmer. Our climate has both been warmer and colder in the past, but we believe our current changes are currently unprecedented. That's where the problem becomes. What do I mean? Well, this is about 900,000 years of climate. You can see that climate has changed previously, correct? What do you see about these changes? Has it been warmer than it currently is? Absolutely. It absolutely has been warmer than it is currently. Has it been a whole lot warmer than it is currently? Yeah, about 5. No. Yeah, 4 degrees Fahrenheit warmer than it is currently, on average. Do you see time periods that look like they could have been glacial time periods where it got very cold? And interglacial time periods where it got very, very warm? Here's a bigger question. Are you surprised at how little the average surface temperature has changed over the last 900,000 years? We're going between 48 to 61 degrees Fahrenheit is our average temperature. Which is why when we talk about a rise in temperature of 2.5 degrees Celsius, so like 4 or 5 degrees Fahrenheit, it's a big deal. And the rate of change here is pretty fast. Has it been faster? Probably. So showing you the ice coverage in the Northern Hemisphere during the past 18,000 years before present and today. In the last 10 to 12,000 years, we've had this relatively warm, stable climate. It's good. As a matter of fact, we believe that that stable climate is what led to humans being able to spread throughout the world and to create human civilization as we understand it today. That without the stable climate, that would not have been possible because agriculture would not have been possible. But we got a larger population. We transitioned to agriculture instead of hunters and gatherers because of this. And then we started building cities. And then over a long period of time, we started creating pollution. But the other part of this is that as we were able to adapt so well to the climate, we were able to kind of take nature and twist the relationship that we had with it. We made nature something that we were in control of, as opposed to something that was in control of us. So we changed that relationship. Is that the relationship we're supposed to have with nature? What relationship do you think we should have with nature?
Balanced.
Some of a balanced relationship? Should we take care of it versus like be a tyrant over it? There's a big difference between being a horrible dictator versus the relationship that we really think, if we were to understand it well, in modern day we really can't understand it well, but we think that the relationship that was meant when the word dominion was used in Genesis which isn't actually the word dominion. That's a totally different thing. But we think that the word dealt with how feudal lords and the people that lived in the town that supported the lordship were related to each other. That when the serfs, is that the right word, would bring the food, and that their feudal lord would provide them with protection. And that in times where their lives were potentially on the line, he would protect them and save them, and they would alternatively bring things back towards him and serving him. And that it's supposed to be that type of mutual serving that we're supposed to have with nature, but that's not what we developed because we realized we didn't have to. This is our temperature change over the past 22,000 years. And you can see that nice stable. Notice that this scale is really bad, by the way. The scale of time on the bottom is pretty horrific. But you can see that the last 10,000 years is fairly stable. And agriculture established right at that time of stability, which does beg a question of whether or not we established agriculture and climate became stable, or climate became stable because we established agriculture. But we think that we established agriculture because climate was stable. We talked about this a little bit. I think we talked about this actually a lot in lab. So there's the average temperature and climate changes happen over time, and we cycle between ice ages and interglacial time periods. And the natural factors involved in this are the Earth's orbit around the sun. What shape is the Earth's orbit? Elliptical. What is our normal angle towards the sun? 23.5. And as the tilt decreases, we warm. As the tilt increases, we cool. The sun has an 11-year cycle of solar activity, although Dr. Bradstreet will tell you right now it is all over the place, and it is not correct. We don't know why. And the sun behaving erratically and differently is true. Could that be part of the climate change we're seeing? Yes. Is it the whole picture? No. You guys looked at volcanic activity in the lab. Did volcanoes cool the Earth momentarily for a couple years? Except one of you had a volcano that made the Earth significantly warmer for a brief period of time. But in general, volcanoes tend to cool the Earth because they put all of the ash into the atmosphere, which decreases solar radiation in. And I mentioned that there's these chaotic systems that we don't really understand. CO2 does play an important role. It increases temperature. It hangs around as a greenhouse gas for a really long time. Arrhenius recognized it as being related to global temperature in 1894. He published it in 1894 that increases of carbon dioxide in the atmosphere, likely due to fossil fuel burning from the Industrial Revolution, would increase the global temperature. How many of you are just like, really? We've known it for this long and people are still like, it is not happening? But it's not just carbon dioxide. The problem is that we are adding carbon dioxide to the atmosphere faster than it's coming out of the atmosphere. If things were in balance, fossil fuel burning wouldn't matter at all. Well, okay, other than all of the other pollutants in it. But carbon sequestration is not happening. The carbon is not becoming trapped in biomass again because we've gotten rid of our trees. We've done deforestation. We have polluted systems to where they're not as healthy, so they cannot continue to keep growing biomass. Arrhenius had linked it directly to coal use during his time period, but we see that there's other things today. Methane and nitrous oxide are by far worse than carbon dioxide when it comes to climate change and warming of the Earth. By far worse. Does methane come from fossil fuel burning? No. Where does it come from?
Meat production.
Meat production. Where else does methane come from? Decomposing trash. It also, the biggest threat we have right now, there are some small methane seeps on the bottom of the ocean floor that release methane gas. Those have always happened. But the biggest threat for methane gas hasn't happened yet. If the permafrost melts, methane gas is going to be one of the #1 things produced because of all of the bacterial action there. It is currently too cold for massive methane production under the permafrost. But that is one of our fears, is that when it gets warm enough, that's going to set a large positive feedback loop. How about nitrous oxide? Where does that come from? Some of it is burning fossil fuels and other human activities that have modified the nitrogen cycle. We have temperature change on the bottom, carbon dioxide change on the top. Do these look similar? Do they look similar at times? Are they following the same trend? Can we then predict which one is causing the other? Or do we just say that they're going together? They're in phase, right? So the top is atmospheric CO2, the bottom is surface temperature. This is from 1950 to 2010. Because when we looked at the last graph, it looked pretty clear. But here we can see that there's some noise in the temperature signal. All of this up and down, if you're studying these trends, you're going to call that noise. So it's going around a central thing. You can see that if we were to plot a moving average line, it would be an increasing line. It would look similar to that CO2 line at the top, which is constantly increasing with very little noise. So how do we study climate? Because we can study the climate today. We can study the climate perhaps from human history because we have records. But how do we study it from when humans weren't here or where there aren't human records? You all learned in elementary school about tree rings, right? And that you could count them. And you could tell by the width of a tree ring if it had been a year of drought or a year of a lot of rain. At least I'm hoping you all learned this in elementary school. So you've known that for a long time. We use tree rings. We use ancient fossils, particularly for reconstructing ocean climate and thereby using that as a proxy for world climate, because we know that certain types of organisms live in certain temperatures. So if we can date a layer of sediment and we can figure out what the fossil assemblage shows us, we can figure out an approximate temperature. Isn't that amazing? The fossils that I worked on for this were diatoms. Diatoms create silica frustules, like shells around themselves, which actually trap air bubbles. If you can get them clean enough, you can test the air. We usually didn't test the air, but we tested the carbon and nitrogen that was trapped inside of them, and you could use that to figure out the approximate information about the carbon in the atmosphere, because you could see how much is carbon-13 versus 12 and use the ratios to figure out about carbon dioxide levels. Marine sediments are used for this all of the time. We can take an ice core and measure the carbon dioxide of the air bubbles trapped inside of the ice core. We have human records from the 1800s for most areas of the world, if not longer. We have what are called long-term observation time series locations. Two of my favorites are BATS and HOTS. BATS is the Bermuda Atlantic time series, and HOTS is in Hawaii. They are measuring climate directly. There are places where it is far from land, so they're able to more directly measure climate. We started measuring the climate directly with satellites in 1982 using infrared sensors. We also use all of this data to run it against math projections to see if we can back forecast information and to verify those with the data that we have. This is using the data we have from 1880 to 2011. There's an increase. Not much of an increase, just 1.5 degrees Fahrenheit. But if every 130 years we increase 1.5 degrees Fahrenheit, it's going to add up quickly. This is from the Mauna Loa Observatory as part of the HOTS system, and this is showing carbon dioxide. You all looked at this data in lab, and you found that the reason there were cycles is because there was seasonality to things, and that's why we have a little bit of noise here. And then you have that line. And this is just our changes since 2001 to 2006. We looked at these in lab. This is the last thing I wanted to show you. These two graphs for me are the most meaningful. That side is what would happen if we only looked at natural factors like the sun and like natural system changes. You can see that the model results in gray do not match the observations. When we add in the human factors, the burning of carbon dioxide, the burning of fossil fuels, the clearing of the land, the meat production, the model matches the observation. Having said that, if I had just human factors on here, it wouldn't match either. You can't remove either part from this discussion. Next time, we're going to pick up with I haven't posted it, but I did record it. I recorded this one too. I'm going to make them into video files during lab today and post them for you. Yeah. So we're picking up with climate change. Is this happening? I'm not just going to answer yes. I think we need to look at evidence, right? Because I could tell you it is, but how do you know that I'm telling you the truth? Hopefully you trust me and you believe I would tell you the truth. But you need to be able to answer this question. One of the first things is that glaciers are melting at record rates. Last year, there was a chunk the size of the state of Delaware that broke off of the Antarctic ice sheet. Delaware is not a big state. You can drive from the top of Delaware to the bottom of Delaware in slightly about just over 2 hours. Having lived in southern Delaware and taken courses in northern Delaware, I know this. You can drive across the state of Delaware lengthwise in about 45 minutes. So it's not massive, but an ice chunk the size of the state of Delaware is massive. There's been a decrease in the Arctic polar ice. It's decreased in size by about 10% per decade since the 1970s, which is bad. But the real problem is it's also gotten 40% thinner since the 1970s. So it's decreased in size, but it's also thinner. What do you think is the difference between thin ice and thick ice when it comes to an ecosystem? Because we should think of the ice in the Arctic, and in the Antarctic for that matter, as an ecosystem. It does support life. It is a necessary part of the ecosystem. Why is thin ice bad? Because animals can't walk on it. And what happens when the animals can't walk on it? They can't hunt. They can't travel. They fall through. They get stuck. You've all at some point in time, I'm certain, seen one of the pictures of the sad-looking polar bears. That's kind of like the picture for climate change, isn't it? But it's not just the polar bears. It's the seals that are going to be affected. It's the whales that are affected. Because this is perhaps the saddest part of the decrease in polar ice. There's been so much of it that there's been an uptick in oil exploration in the Arctic. So now these areas are ice-free, so we're realizing that we can use them to extract more fossil fuels from the fossil fuels that are buried in the Arctic Circle, which then is a self-perpetuating problem. there are heat waves and extensive droughts. This isn't news to you. You've seen this basically your entire lifetime. The 10 hottest years on record in human modern records have all happened within your lifetime. But there's been a change in precipitation. How much? Overall, we're getting 1% more precipitation than we used to. How do you think we're getting that?
More water.
There's more water because there's less ice, so more water is evaporating, we're getting more rainfall. So eventually rainfall will keep increasing a little bit. At some point it's going to hit its maximum, but for the near future we are going to see an increase in precipitation. But this isn't an increase everywhere, it's an uneven increase. We're lucky where we live right now in this. We're on the receiving end of more precipitation. But Sub-Saharan Africa, Australia, Southwest, West Coast of the United States, these are places that are on the receiving end of less precipitation. You know there's been a rise in tornadoes and violent storms. How many of your parents or grandparents have remarked on the fact that the hurricanes and the nor'easters have gotten more frequent and worse? And there's mounting scientific evidence of rapid warming of the Earth. So the question is, are human activities causing it? There's a strong correlation between an increase in the atmospheric CO2 and the Earth's surface temperature. We looked at that graph last time. The first IPCC report, which is the International Panel on Climate Change, it's a group sponsored by the UN made up of atmospheric and climate scientists from around the world. Their first report came out their most recent report came out in 2007. The first report came out in 1990. They also had reports in 95, 2001, and actually they've had one since 2007. I think it was maybe 2014 there was one. I haven't read that one yet. But in 2007, their biggest report said that there were various sources of climate change. Human sources are greater than natural sources. We've talked about natural sources already. This is sun behavior. This is the Earth's rotation. This is the Earth's elliptical orbit. Volcanic activity, El Nino, La Nina, global ocean circulation patterns. But what are the human sources other than carbon dioxide because I drive my car? You guys know what they are. Farming, especially production of what? Animal production, meat, especially red meat, produces methane, but it also produces a lot of carbon dioxide. And ranching and things like that require the tearing down of a lot of crops. If we do that, tearing down a lot of trees to grow crops and do ranching. So deforestation doesn't allow us to use trees to offset the carbon dioxide production. Slash and burn for farming, where they cut down all the trees and they burn the whole area, reduces tons more carbon than the plants would have been able to store. CFCs are actually involved in this. They can help a little bit with global warming. Methane from cattle, methane from trash rotting in trash dumps, methane from melting permafrost. Those are all adding to this. And the NOx gases that come from incomplete burning of fossil fuels, the nitric oxides, they're going to add to climate change. And not all carbon dioxide that we produce, in fact, very little comparatively of the carbon dioxide that we produce that is related to climate change comes from our cars. Something like 13% of the gases that contribute to climate change come from driving cars. But that's always what you hear. Well, how else do we generate carbon dioxide from human pollution?
Homes.
Your homes? Power production? We burn a lot of fossil fuels for that. We've been using, the IPCC came to three basic conclusions. The first was that since 1980, so in all of our lifetimes, the lower atmosphere has warmed significantly. That's where most of the warming's been happening, the lower atmosphere, part that's closest to us. The computer models they have run have been predicting temperature since 1900. These models indicate that it's related to human activities. As a matter of fact, they've run the models multiple ways. Once with natural factors only, once with human factors only, and then the only model that fits the data is if you run a combination of natural and human factors. There are natural things that are causing warming and cooling. There are human things that are related to both. So, well, at least to warming. So it's actually both sources we need to include for looking at what's happening to global climate shifts. The other conclusion that they found is that climate is currently changing and it's going to continue to change. It's going to continue to warm overall and become drier. What are the problems? Rapid atmospheric warming. Lots of evidence. It's gotten worse since the 1980s. And it's linked to carbon dioxide. No shock. In 1850, the carbon dioxide level in the atmosphere was 285 parts per million. By 2011, it was 393 parts per million. We passed 400 parts per million about 2 years ago. That was always the level that everybody was scared of happening too soon. And it did. The U.S. has produced a lot of it. 450 parts per million, we believe, is the tipping point for carbon dioxide in the atmosphere, after which things will get much worse. We're not there yet, and we have time to stop it from happening if we start taking action soon. We've done about 25% of the excess carbon dioxide produced since 1850. China's only done about 5%, in part because their industrial revolution, their energy production just started, 40, 50 years ago to ramp up, whereas ours has been happening for over 150 years. Soot is also a problem with climate change. What color is soot? Black? What do you know about the colors white and black when it comes to absorption and reflection of energy? Correct. So if there's a lot of soot in the atmosphere, what is that going to do to heat? It's going to trap it. It's going to absorb more. It's going to keep it reflecting in. So it's not just the carbon dioxide, it's the soot that's coming from the incomplete burning of carbon-containing material that is getting in the atmosphere that's actually adding to warmth. And what about livestock? This is where I'm going to tell you the numbers are massively different for what percent of climate change is related to livestock. Massively different. From 51%, which was from World Watch, it's a number from Goodland and Hein in 2009, down to about 11%. Oh no, that actually I forgot. Fell 2016 said 4.2%. No one really believes that number. It might be 4.2% is just U.S. numbers, but that's low. 11% is usually seen as the lowest. The UN has often said that the number is between about 13 and 16% of greenhouse gases come from livestock production. The question is, which numbers do we trust? And it depends how much livestock production we do. Beef produces 5 times more greenhouse gases than does chicken. So we could switch to chicken and fish, which produce less. Andrew has had an awesome idea in a couple of his journal entries. He would like us to switch to eating a lot more wild meat, which we then don't have to farm, and it allows us to keep forests, and it would not have a massive impact then on greenhouse gases. Any of you think that's a good idea? That we could get people to do easily?
I was just actually listening to a podcast. They were talking about the explosive numbers of wild pig populations.
Yes!
And like how it just literally tastes the exact same as domestic pork, and you wouldn't have to pay for it, no one have to farm it, and they're destroying farms, so like there's really no reason not to kind of corporatize it.
I feel like people would be really like into seeing like wild boar and stuff like that on the menu and be like, I'm
Yeah.
eating that.
There's the problem though, that there's a lot of humans and we could potentially hunt some of those species.
But how many deer are there in Delaware County?
A lot.
Enough to feed people.
There's also a lot of passenger pigeons.
There were a lot of passenger pigeons, and that's right. But here's the problem with that. We didn't kill them just for meat. We killed them for sport and fertilizer.
It's a different kind of population too.
Yeah.
Like they were like, you could either have like 1 billion or 0 of them. Like, then they need like extremely high amounts of like colonies, high population of colonies to like survive.
Anybody ever eaten rabbit? I feel like Dr. Vaquero would be crying right now with us talking about this because she is a pet rabbit. How's rabbit? My dad said rabbit's really good. It makes me kind of sad to think about eating rabbit, but rabbits reproduce really quickly.
Yeah.
It's something that we could easily do and eat. It's something our ancestors ate. It would work. Deer? Can't deer, like, what is it? A group of like 6 deer can, within 10 years, have over 200 offspring, something crazy like that?
I'm not sure. They reach sexual maturity at a year, but like I was reading something, and they only have like 1 or 2 offspring a year. But like with the wild pigs, they reach sexual maturity at 6 months old, and then they can have a litter of 6 that year.
That would
So
work.
the numbers are
That would replace our pork farming.
Yeah.
And Sarah, how do you think vegans would feel about eating wild meat as opposed to farmed meat?
Well, we're definitely preferable.
As if they're ethical vegans about farming practices, right?
Yeah, they're vegan because of farming. They'll probably eat well.
I think it's a good idea. And that would offset these numbers. Livestock produce half of the world's emissions of methane. But maybe we could switch to something else. That is an easy fix. This is from UC Davis about how livestock, they believe, figure in to U.S. production. And they're basing this on EPA numbers. Of that 4.2%, they say comes from livestock, 2.2% come from dairy cattle. Not cattle that we eat, but dairy cattle. So they were making the point that our reliance on dairy is problematic. Is anybody going to argue that we should give up cheese, milk, and ice cream? Yep. We got one hand. How many of the rest of you are like, no, I need my cheese and milk and ice cream?
We could eat less.
We could eat soy milk.
There's a lot of good milk substitutes.
There's some good soy ice creams.
Coconut milk.
Goat cheese. We could do that, right? Vegan cheese? I don't know. Maybe. But the argument is that livestock pales in comparison to transportation and energy production. However, livestock could be an easier switch because I think you're going to get people to eat wild boar faster than you're going to get them to install solar panels on their house or a wind turbine in their backyard. This is from Skeptical Science about farming emissions, and I actually liked that this shows the post-emission, so post-farming emission versus production emissions. So the post is like after the animal has been slaughtered. Because what you notice is that, like, and this isn't just for animals, notice that potatoes, almost all of the greenhouse gases that potatoes emit comes from processing, transport, retail, cooking, and waste disposal. Turkey produces a lot, too, and farmed salmon from after farming. Other problems. I've not mentioned melting ice. It is important to note that the Arctic has increased about 5 to 7 degrees Fahrenheit since the 1950s. So we talk about the whole world average being a 1 degree Fahrenheit difference. For places like here, it's probably about 0.4 degrees Fahrenheit warmer since the 1950s. But the Arctic makes up for a lot of our not warming. Gosh. If the Greenland ice sheet melts, we will see a sea level rise of 23 feet. And the biggest problem of this, if you read anything that talks about a breakdown of the global circulation, you know what the world looks like, what the oceans look like. So the way that global ocean circulation works, this is my 30-second spiel on that, is the water starts from the Arctic, and it's storming out there. There's cold water that comes down from the Arctic. It's going to go past Greenland and Iceland. It's going to sink. And as it does, it's going to transfer the heat and things down through the Atlantic, down through the Southern Ocean, around the tip of Africa, a little bit, but most of it is actually going to go out to the Pacific, around the Indian Ocean, and then back up to the Arctic again. So there's this loop that the water travels. The concern is if the Greenland ice sheet melts, it's going to melt a lot of fresh water into the ocean. Fresh water doesn't sink. It floats on salt water, unless it's really cold fresh water. But this is going to be warm fresh water because it's coming from a land surface. That is going to create a warm lens of fresh water on the top of the ocean. You all know I love oceans. I'm an oceanographer, so this is my thing. What happens to warm water that's fresh water, do you think, with animals that live in the ocean and with phytoplankton that live in the ocean? It's really problematic. It's going to change our whole structure. It's going to decrease ocean productivity, but the bigger problem is that it's going to, well, potentially, I don't believe this, but it's in the literature, that it could shut down the global conveyance of heat through ocean circuits, because it would break down the entire deep water circulation of the ocean, because the water that should be going to the bottom no longer would be, which would mean that England is suddenly really cold. Italy, what is that in line with in the United States? We look around the globe. What would you guess?
Virginia?
Yeah, try Maine. New England. But it's warm, right? Because of the global circulation patterns, the heat transfer and things like that. Maybe not quite Maine, but it's way further north than we think it is. England is in line with Canada. Cold portions of Canada, but it's warm. France is further up than we think it is. All of these things are further up in latitude, even though we're used to them being warm, in part because of global circulation patterns. If that breaks down, I'm not really sure what will happen. Sorry, that was scarier than I expected it to be, potentially. This is the Muir Glacier. These pictures, I looked this up last night, are from, I believe it's August 13th, 1948, and August 31st, 2004. They're both August 48 and 2004. That's terrifying. Permafrost, I've mentioned, it melts, it releases trapped methane, and sea level rise. The glaciers melt, sea level rises. There's more water in the ocean. But here's the bigger problem. You all learned this in chemistry. Warmer water increases in volume. So sea level rise is going to happen because the glaciers melt, yes, but because warm water takes up more volume than cold water does. So it's just going to expand. And the expectation is that by the end of this century, we could see a 3 to 6.5 foot increase in sea level rise. Even if we were able to cut our CO2 production where it is today and never have more greenhouse gas production above the levels that we're having today, we expect we're going to see a 3-foot rise in sea level by the end of this century. It threatens about 1/3 of all coastal species, not the least of which are your coral reefs. But the biggest impact is going to be on people, the climate refugees that are going to be displaced by a 3-level rise in sea level. For nations like Tuvalu, where the whole country is less than 10 feet above water, 3 feet of sea level rise is going to make the island very tiny. And this is what 3 foot of sea level rise does to Florida. I have some good friends that live in New Orleans. It's not on there. It will be underwater. And if you have friends that are from Miami, I know we have a number of students here from Miami, it's going to potentially be underwater. Good news is Disney World is safe. That came up last time I taught this. They were like, is Orlando okay? Disney World is fine. But all of these people could be displaced. And these aren't even refugees from other countries. These will be refugees from our country. The ocean is warming, but there's also acidification. That CO2 dissolves in, and we get ocean acidification. The ocean is more acidic now than it's ever been, as far as we can tell, for the last 20 million years. This is not caused by methane. This is just carbon dioxide. We expect that by 2100, it will be 150% more acidic than it was in 1800. Why does the acid matter? Many things that live in the ocean make their skeletons and their shells out of calcium carbonate. Calcium carbonate, those who took geology know, dissolves when we put acid on it, because that was the only rock that when we dripped acid on it, fizzed and splurted all over the place. Nancy Knowlton, who is a coral expert, has said that she expects that corals may cease to exist as physical structures by the year 2100 in a lot of places in the ocean. And I refuse to believe in a world where coral reefs don't exist, which is why I think we act now. And we say, no, we're going to fix this. And truthfully, it is your generation, it is my generation that gets the opportunity to do this, that says, things have gotten bad and we're going to stop it now. Because think about it, how active would your age group be in saying, this is unacceptable? We're going to change it. You're doing it with other things. I don't think any of this is news to you. I think we've talked about this. Intense heat waves, damaging storms, blizzards, and that number for drought we covered when we talked about drought already. Not shockingly, food production is going to be a problem. There will be better areas for food production. Do you know where we're going to be able to do amazing food production with climate change? Canada, Russia, the Ukraine, Siberia. You're shaking your head because we're not on good terms with Russia and the Ukraine.
It sounds funny, like growing food in those places.
Can you imagine fresh grown lettuce right from Siberia? I told you there was going to be some positives. Also, the growing season here is going to be longer. How many of you want to garden at home? Maybe you could get 2 sets of crops out a year because the growing season is going to be longer, because it's going to be warmer year round, so you're going to get a longer growing season. So there is a benefit to this. As I told you before, it's going to cost way less to cool your house. I'm sorry, way less to keep your house warm. More to cool it. But the biggest decline in food is going to be in tropical areas and in port areas and in drought-prone areas. Sub-Saharan Africa is expected to be hit the worst with food reduction due to climate change. And then there's the threats to human health. Every summer you hear on the news, and this week 10 elderly people have died from a heat wave, right? Or stories like that. People die in heat waves. Warmer weather is more favorable for insects. We expect insects and insect-spread diseases will spread with climate change, creating health problems that we don't know how to cope with. West Nile virus, Zika, malaria will spread dramatically. This is when you're going to hope that you have sickle cell, or at least one trait for sickle cell, so that you will be able to survive malaria, or that we figure out how to treat these things better. And that's the option that people in public health and healthcare are going to have to worry about, is how do we treat these diseases? But then hunger and malnutrition and refugees will be problematic. Biodiversity is going to decline for some things. For other things, it's increasing, and it's actually doing better. Tree sparrows lay eggs now 9 days sooner than they did in the 1950s. We expect that they will at some point be able to raise 2 clutches of eggs a year, allowing the swallow population to increase dramatically. Bullock's oriole is expanding its range northward. Those are good things if you're a birder. Polar animals are going to decrease. And the numbers of what could go extinct, if we see a climate change of about 4.5 degrees Fahrenheit, 1 in every 3 land-based plant and animal species will be at high risk of extinction. If we warm by 6.3 degrees Fahrenheit, it will be 7 out of every 10. So let's not get there. There are 2 ways you can respond to this. There's the way the first book that we read about climate change responded, which is, it's really bad. Look, here's 3 people that are doing things right. Then there's the way you can respond that the book that Moo and White are writing are talking about, saying, but I'm a Christian, and my job is not to sit here and be defeated and be a fatalist and say, this is going to suck. That's okay. It's to say no, because I have hope in Christ, I have hope in God, and I believe that he is going to help us. Not that he's going to magically fix everything for us, but that we are to take the steps as people who are bringing redemption and hope to the world to make things better. How do you think we do that? We're going to skip these slides. You can go back and read them later. So how do we avert disaster? You reduce greenhouse emissions quickly, now. How? Conserve energy. This is not new. We talked about this in our energy chapter. Can make energy more efficient. I'm going to go around the room and I'm going to make you tell me, each one of you, including our visitor, how do you think that we could conserve energy or be more energy efficient? I want one suggestion from each person. Who wants to start? Do you want to start since you're our visitor?
Sure. Carpooling all places.
Perfect. Which way should we go? You get to pick. Sarah, you're up.
Everybody upgrading to better light bulbs.
Carpooling, better light bulbs. These are easy. Andrew.
Is it CO2 emissions? Or greenhouse gas?
You can pick any one of them. I was going with energy conservation and efficiency, but you can go with any of them.
Trying to switch to sustainable energy sources.
Sustainable energy sources, which will work with energy conservation too. Emma.
Turning things off when you're not using them.
Yeah.
Leaving the lights on or the TV on, whatever.
Elizabeth?
Finding alternative food sources. Like,
Yeah.
vegetarianism.
Yeah.
I know we talked about using seaweed as a.
Yes. We'll eat more seaweed, less corn.
Build buildings that have like really large windows and we can rely more on natural light.
Either of you.
I was gonna say like solar cells or like if you can't look at like hybrid or electric vehicles.
Following up on the 2 of them, building houses with better insulation so that you require less heating or cooling.
I was gonna say use cold water instead of hot water whenever like you can have the opportunity.
Yeah.
Try to use build more open buildings that you can get more airflow and not use as much cooling.
Are any of these, with the exception of changing how we've built buildings, difficult to implement in our daily life? I think the biggest problem, and I think the fastest way to avert disaster here, is that people think that they have to do something big. But if we can get everybody to realize that it's little tiny steps and that everybody comes together and turns the lights off when they leave the room. Do you know what Dr. Unander does when he leaves? He goes through all of the labs to make sure that the lights are off because he doesn't want to leave with the lights on in the labs because it's a waste of electricity. Did you know that he does that? I think it's really cool. I think it's great. I do the same thing. When I'm walking out of the building and I'm walking down past the first floor of McGinnis and I see that there's nobody in the classrooms with the lights on, I open the door and I go in and turn the lights off. If there's people in the classroom, I don't do that. But it's little things like that. You said turning off our televisions a little bit, right? If we're not watching it or something, and turning off our lights if we're not using them. Those are very simple things we could do. We could, I don't know, the school's something good at this. We could maybe like not leave our computers on all the time. I think I'm supposed to set my computer updates at night, but maybe they could change it and have it update like during my lunch, which would force me to like eat lunch away from my computer. I feel like that would be good. Are these easy steps we could take? You know, a really easy one, and I hope you all use this one already, is that you are not going to get plastic bags at the grocery store. You bring your own reusable bags. It produces less waste, and it also produces less energy, or it uses less energy, because by reusing the bags, there's not the energy spent on producing the bags every time. If we shift to low carbon sources of energy, we expect that we should be able to get between a 40 to 80% reduction in greenhouse gases by 2050 if we start switching now. Think about what that would be. How amazing would that be? And we could do that. We can plan for unavoidable levels of change. Some things are going to happen anyway. We plan and we go with it. We change how we do agriculture. We change what we eat. We start doing those things now. And we learn to mitigate the effects of climate change. Carbon sequestration, I've mentioned this before, the idea that we find ways to take the carbon out of the atmosphere and store it in biomass. How do you feel about global dimming? What do you think global dimming is? It's not as tragic as it sounds. What happens when you dim the lights?
You use less energy.
Yeah, so global dimming is a little different. We're going to decrease the amount of sunlight that enters the Earth's atmosphere. How do we do that? It's a little crazy and kind of expensive. So we got some options. We're going to take some satellite space shields. We're going to shoot them up into the atmosphere. They're made of mirrors. They're going to reflect the sunlight away from us. This will reduce the sunlight and the radiation coming into the Earth's atmosphere. I think it's safe to say a lot of these were not developed by scientists, or at least not like biology, environmental scientists, by the way. I'm thinking these were like politicians in a room and they were like, we've got to have some ideas here. Stratospheric reflective aerosol dispersal using balloons because they didn't want to use airplanes. The other option is airplanes. So you have these balloons filled with aerosols that go up into the atmosphere. They're these little white particles that are going to do the opposite of the soot. They're going to reflect the light out. It's great. Cloud brightening with seawater. We're going to create more clouds, which will reduce. We're going to do this by evaporating ocean water. That will reduce the amount of albedo. It'll make things better. What do you think? Is that good? Do you think the other ideas are a lot better?
My initial concern is what would happen to the agricultural industry. What if they dimmer or would they lessen the amount of sunlight?
No one's really worried about that in this plan.
We make enough food. It's just like
Right. We currently make enough food to feed every person. It's just we aren't good at getting it places and storing it.
I was just curious as to whether or not that would have a
It would?
significant enough effect to consider not doing this.
Consider not doing it. There's sheets in the
Is this a legitimate idea? They want to build.
Is this a legitimate
they
idea?
want to
I
build
think for a
flying
few people,
saucers to cover the entire
It's-
circumference.
not the entire planet, but I think for some people these are legitimate ideas.
this is I love this. This is
No.
fantastic.
For most of us,
Materials are-
this is about as ridiculous as when I told you that we were going to fertilize the ocean by tossing iron filings off the side of boats, and that phytoplankton communities were going to increase, thereby allowing carbon sequestration. Maybe the flying space shields are even worse of an idea than that. But these are ideas. This is what happens when you allow people to sit around and talk about how do we save the world. They come up with some really crazy ideas, and they overlook the obvious ones that you all came up with in 30 seconds. You know how somewhere along the line you probably were like, this idea was given to you, like, you're really good at science, but not art. You're not really creative, maybe for some of you. Or that like science isn't a creativity thing. Science is creative because otherwise we get people coming up with space shields. Cody's in love with them, but no one else is. And we need your creative problem solving skills. But we just need them to be realistic.
Some spent my poop pills.
Food pills were worse than this. Sorry. They were.
What is that? Pumping CO2?
Oh yeah, the pumping CO2 into the ground. I like that one too. So we're going to take the CO2 in the air and we're going to filter it out. So we're not like pumping the oxygen and the nitrogen down. And we're going to pump it into two places. One is like the deep saltwater aquifers, which is going to make them more acidic, but no one's worried about that. But my favorite part is we're going to put them in the depleted coal and oil and natural gas beds, so thereby replacing what had been taken out by fracking with air, so that it shouldn't affect the ground surface as much. No? Doesn't it sound good? Maybe not as good as turning off our lights, eating less red meat, and driving hybrid cars and solar panel cells and carpooling. So we have then two approaches to this, and you guys have already chosen, with the way you talked about it, the idea that prevention is better than cleanup. All of these are cleanup. None of these are prevention measures. How do we get everybody else there? Shame. We're going to shame them. Thanks, Cody. You used too much carbon dioxide today. Stop. No. No. I'm going to ignore you. Elizabeth.
We can always start early. I know my parents have complained in the past that kids aren't taught to
Yes.
turn off the water, turn off the lights after themselves.
Yes.
Oh.
What if we started teaching good practical science in kindergarten? What if we had like television shows that showed scientists not as like strange people or people who just like solve crimes with dead bodies, but as people, or as Indiana Jones? Like I feel like those are the way that we have like sciencey people, but as regular people who are solving the world's problems. I don't know what that would look like. What if we have scientists running for public office? There are. Not in Pennsylvania this time around. I don't think. Maybe one of you can be that person. International cooperation. Kyoto Protocol is one of them. Then we have the Paris climate meetings. One of the ideas is a technology transfer program, and this is the fact that your most developed nations are going to have to bring down their emissions first, and they're going to develop the technology to do that. They will then give the technology or lease it or sell it cheaply to the other countries. That way they're not having to always play catch up. We can tax carbon dioxide emissions. We can shift government subsidies. We can do cap and trade with carbon dioxide like we've done for nitric oxide and sulfuric oxides that worked for air pollution. We can slow population growth, eat fewer animals. We can do all of these things. We literally can do every single one of these things. It's making the decision to do them. Is climate change going to be difficult? Yes. Does it have to be horrible? Not if we avert disaster, which we can do. And I think that's the biggest thing. It's also not on here, but the biggest thing is to get people to believe that it's happening and that it's real and that it's important. You hear Dr. Unander talk about Costa Rica all the time, don't you? Have you ever heard about their energy plans? By 2030, Costa Rica will be the first country in the world to go completely carbon neutral with their plans. Norway is expected to become carbon neutral by 2050. There are 32 states in the United States, and actually there's probably more now. In 2015, there were 32 states in the United States that had climate action plans and governors who had committed to fighting climate change. There are 650 of the world's largest cities that have come together to talk about how do we lower emissions. Even SEPTA and UPS have hybrid vehicles. We just need to start working. I want to talk about our climate change articles next time for a little bit. And then I'm going to ask you guys a very, perhaps, difficult question. Do you want me to talk a little bit about Love Canal before we talk about waste? Do you know what Love Canal is? How many of you know what it is and why it's a problem? Okay, we're going to talk about a little bit of it then. So we'll talk about a little bit of that probably next time after talking about the articles. Sorry we didn't get to the articles today.